All right, now we're going to move on to number 2 for proofs assigned on April 3rd. Here's what we have. We have a triangle, a rather large triangle, ABC. And we have 2 segments inside of the triangle that originate from point A. We've got D and E. Now, what is given to us in this problem is that these 2 angles up here are congruent to one another, and these 2 triangles down here are also congruent to one another as well. Now, as soon as I see this, all I think of is label things congruent, meaning because of these angles being congruent, this creates 2 isosceles triangles, ABC. Okay, I'm sorry, not ABC. I meant to say AED is an isosceles triangle because of the isosceles triangle base angle converse theorem, which says because of the base angles being congruent, now these 2 sides opposite, those 2 angles, are now congruent to one another as well. Now, what we're trying to prove is that these 2 segments down here, EB, is congruent to DC. And if I can make sure that these 2 triangles are congruent, I can go ahead and say that by CP/CTC, these 2 segments must be congruent. So far, what I have in these 2 triangles is an angle and a side. What I would need is either another angle, and it could be this one down here, or it could be an angle that's right here, and it would give me ASA. If I were to choose angle C to be congruent to B somehow, then I would end up using AAS. But if I can go ahead and prove that ADC, which is this angle right here, is congruent to angle AEB, which is this angle right here, then I'm going to end up using ASA to prove those 2 triangles congruent. Well, there is an easy way to say that these 2 dotted angles are congruent. If you guys remember, we have looked at linear pairs before. We can identify AEB as an angle and AED as another angle to be a linear pair by definition of linear pair, which says these 2 angles are supplementary because of the linear pair postulate. Therefore, this is supplementary to this angle. And then I can say ADC and ADE as angles are also a linear pair, therefore they're supplementary by the linear pair postulate. But I also know that these 2 angles are congruent to one another because it's given. Therefore, angle AEB, which is this single dotted angle, and angle ADC, which is this other single dotted angle, are not congruent by the congruent supplement theorem. That theorem says if an angle, or if 2 angles are supplementary to the same angle or to 2 congruent angles, then therefore those 2 angles must be congruent. That gives us this additional piece of information that we can now mark that says this angle is congruent to this angle. Therefore, triangle AEB is congruent to triangle ADC by ASA, triangle congruence theorem. And then to conclude this proof, you can go ahead and say that segment EB is congruent to segment DC by CP/CTC. And that concludes this proof.